Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the course of Introduction to Computing, CS101. It's lecture number 48, and today we will discuss about Central Processing Unit. So, what is today's agenda? Today we'll discuss about what is Central Processing Unit, and after that we'll study about components of CPU, Central Processing Unit, and how it works, working of a CPU. And this is the part 1 of the lecture, and then later on in part 2 we will study about the architecture of CPUs, different CPUs architectures like Intel CPU and AMD CPUs. Then we will see how those architectures works together. So what is a CPU? CPU is the abbreviation of Central Processing Unit. You have heard this term so many times. Central Processing Unit. It is the main component of a computer, and it processes instructions. So the main job of a CPU is to process instructions, and this is the main component of the computer. Without CPU, the machine is a dummy machine. This means that it's an ordinary machine if it has no CPU. But with the help of the CPU, Central Processing Unit, we called any machine a computer. And the third point is it runs the operating system and applications. The primary job of a processor or a Central Processing Unit, we use interchangeably. Sometimes we say CPU and sometimes we say processor. So both the terms are the same and we use them interchangeably. So the primary job of the processor is to run the operating system and different application programs like MS Office and MS PowerPoint, MS Word, and similar types of applications. So this is the main job of the CPU, and it constantly receives input from the user. This is the second part of its job, that it constantly receives input from the user or active software programs. So the input comes either from the user or the active software programs. And the fourth point is it processes the data and produces output. This is also its job, that it processes the data and then produces an output which is visible to the user either in the soft form or in the hard form, so which may be stored by an application or displayed on the screen. So there can be a scenario where the output can be stored in an external system, and that external system is maybe a file. We have seen this thing. We can store the output in an external application, which is a file, or we can say that this is a database as well. So the output can be stored in a file or in a database as well. Okay, and we can see the output on the screen at the same time. So the primary job of the CPU is to process different instructions, and those instructions are given by the user in the form of an input, and those instructions can also be from an operating system or any application program that is installed. So this is the job of the CPU, to execute different instructions and to keep the systems running all the time. The CPU contains at least one processor. So this is the limitation. This is not the limitation. It means that it contains at least one processor. There are multiple processors that are nowadays coming in the modern CPUs, and which is the actual chip inside the CPU that performs the calculations. So most CPUs only had one processor. This is not true in today's world. Nowadays we are working on Core i7 and Core i9 systems. So in that case, one processor contains multiple cores, multiple independent units, and we call those independent units as cores. So this is not true for today's processors, but now it is common for a single CPU to have at least two processors or processing cores. You have in In the last decade, we have used core to do core i3 and dual core processors. Those processors have only 2 cores, but nowadays we are using core i7 and core i9 processors. A CPU with 2 processing cores is called dual core CPU, and models with 4 cores are called quad core CPUs. Okay, so there are older systems are dual core CPUs, and the modern systems are quad core CPUs. High-end CPUs may have 6 or even 8 octa-core processors. So this is a special case, and these 6 core processors or 8 core processors are coming in the servers, in the older servers. Okay, not in the desktop, but on the servers. 6 hexa-core, and these are specialized processors that are used for special purposes like gaming. Even you can find these processors in desktop application, in desktop version as well, where you are where you want to purchase a desktop for a gaming purpose. For a gaming purpose, the processors have either 6 cores or even 8 cores. So the 6 core processor is called the hexa-core, and the 8 core processor is called an octa-core processor. A computer may have more than one CPU, which each have multiple cores. So I hope you understand this concept. For example, a server with 2 hexa-core CPUs has a total of 12 processors. Hexa-core means 6 cores. So if a server comes with 2 hexa-cores, this means that the server or the CPU has total of 8 processors, and those 12 processors are called multiple cores. So this is the diagrammatic illustration of the central processing unit. Here you can see the input is coming from the input unit. The input unit is there are different input units like keyboard and mouse and some other input units. And you can see that inside the CPU central processing units, there are you will find 2 further components. One is the ALU, and the second one is the control unit. So inside the CPU itself is divided into subcomponents. One is the ALU, and the second one is called the control unit. So ALU stands for arithmetic logic unit, and this is the control unit. The function of this unit, which is called ALU, is to perform different operations like subtraction, addition, multiplication, and division. This is the job of the ALU. The first letter A means arithmetic operations, subtraction, addition, multiplication, and division. And the second letter L stands for logical operations. That's why it is called arithmetic logical unit. The first part performs different operations, mathematical operations, and the second part, which is the L, which is the letter L, logical operations, are also performed by the ALU part of the CPU. So combined arithmetical and logical operations are performed by the ALU. You have a knowledge of arithmetical operations, but logical operations are not much relevant to you at this stage. Logical operations are, suppose we are going to compare two values in the form of which value is greater than or less than or equal to. So these special operators like greater than or equal to or less than equal to, greater than equal to, not equal to, not, these are all operations that are called logical operations. So the logical operations are performed by the ALU component of the CPU. Now let's talk about the control unit. The primary function or job of the control unit is to coordinate different parts of the system together. This is the main part of the system of the CPU that controls the communication between different parts. Like the control unit takes instructions from the main memory. As you can see, it takes instructions or data from the main memory and fetch those instructions and data into the processor registers for further processing. And after that, those instructions are processed. It can then again transfer the data to the main memory, from where the operating system's job is to get the data and show to the user. So this part, which is called control unit, acts like a traffic police inspector, which controls the flow of the traffic. So the control unit controls the input, traffic of the data between different components of the system. So this is the input unit, and this is the central processing unit, and you can see, and this is the output unit, and here is also a main memory where the data is stored, instructions are stored, and those instructions or data are moved in and out from the CPU with the help of the control unit. Okay, so this is how the components of the CPU looks like and how it works. So let's move on and see the individual components of the CPU. First, we will study about control unit. This control unit is an internal part of the CPU, and that coordinates the instructions and data flow between CPU and other components of the computer. So this is the primary responsibility of the control unit, to coordinate the instructions and data flow. Okay, these two operations. It fetches instructions and then again put back those instructions to the main memory, and it also controls the data flow between CPU and the other components of the computer. So the control unit acts like a traffic police inspector. It is a control unit that directs the operations of central processing unit by sending timing and control signals. So these are the special type of signals which we call timing and control signals, with the help of which the CPU, other components like arithmetic logic unit, controls and executes different instructions in a timely manner. So those timing signals and control signals are sent to the ALU by control unit. It controls the flow of data between processor, memory, and other system devices. As I have told you before, that the control unit acts like a traffic police inspector, and it sends data and instructions, fetches data instructions from the main memory, and after executing those instructions by ALU in the form of information, the data is stored again in the primary memory or the secondary memory. So the control unit main responsibility is to control the data flow between CPU and other components of the computer. Let's talk about what is arithmetical logic unit. Arithmetical logic unit is an electronic circuitry of CPU that performs all the arithmetical and logical operations. As its name suggests, it performs arithmetic and logical operations on a computer. So the ALU receives three types of inputs. The first one is a control signal from control unit, and the second one is data that it is to be operated, and the third one is status information from operations done previously. So here the status means whether that operation is completed, not completed, in pending, and so on. So this is called the status information of different operations that done previously, incomplete, completed, in pending operation, and so on, and data that needs to be operated, and the control signal. So the ALU receives three signals, three types of inputs. One is called control signal, the second one is data itself, and the third is status information. When all the instructions have been operated, the output that consists of data is stored in memory, and a status information is stored in internal registers of the CPU. This means that when the ALU finishes its jobs of performing different instructions on the data, it then saves the data in the RAM or in the secondary storage, and also saves status information in its internal registers. And what is the purpose of this part? Why the CPU stores this information, which is called status information, in its internal registers? With the help of this information, the CPU knows that which instruction is completed or is not completed, or in a queue waiting for its time to process, and so on. So this is why status information is required at this stage. So all the CPUs, regardless of their origin of type, performs a basic instruction cycle that consists of three steps, which is called fetch, decode, and execute. it's about working of a CPU, how CPU works. It works in 3 steps. First one is the fetch, second one is the decode, and the third one is the execute. So what is a fetch? Fetch means to bring something from to some equation. So our program consists of a number of instructions. Suppose we have written a program in C++ or Java or any other programming language like Python, uh, etc. The purpose of a program is to calculate different operations like plus operation, minus, multiplication and division. So we have encoded those operations in the form of a code, and in that code is called instructions. Okay, so a program consists of number of instructions, and the various programs are stored in the memory. During this step, the CPU reads instructions that is to be operated. Let's say the CPU wants to calculate the add operation between two variables. Let's say we have two variables, a and is equal to b. Okay, and we want to store the result in the third variable, which is called c. So in that case, the CPU read instructions. This is called operand. The plus sign is called operand. Similarly, minus sign is also an operand. Multiplication and division is also an operand, and these are the variables on which this operation is going to be performed. So let's say we are going to add two numbers. So in a computer language, we call this statement as instruction. So the CPU reads this instruction, which is a plus b, from a particular address in the memory. So memory is also playing a very critical role in computer system, because we have written a program and that program is stored in a memory. Okay, so the job of a CPU is to get that program from the hard drive and store that program in a memory. So that program is stored in a specific address in a memory. This program is stored in a particular address in the memory. So it's the job of the CPU to read instructions that is to be operated. Here the instruction is this addition from a particular address in the memory. Here the memory is not the secondary memory, but it is a primary memory, which is called a RAM. Okay, so remember that the CPU always takes data from the RAM. So this is the second step, which is called decode. Decode is for to understanding some particular piece of instruction. A circuitry called instruction decoder decodes all the instructions fetched from the memory. So fetch is the first step, and then decode is the second step of the central processing unit. So in this step, the instructions are decoded to various signals that control other areas of the CPU. Someone has written instructions for a computer to do something, like we have written a program in C++, Java or Python to add two numbers together, like c is equal to a plus b. So it is the job of the decoder, which is called instruction decoder, to decode the instructions for the CPU so that those instructions can be executed in a timely manner on the CPU. So this is the job of the instruction decoder, to decode the instructions that is fetched from the memory. And here is the last step of the process, which is called execute. In this step, this is the last step, the CPU executes instructions. Here the execute means, let's say in the previous example we have declared two variables a and b, and we have stored the result of a and b, a plus b in c. Let's say we have a is 1 and b is 2. In that case, c is equal to 3. So this is the job of the CPU to execute these instructions. We have given a is equal to 1 and b is equal to 2 at runtime, and the job of the CPU is to execute the instructions. By execution, we means addition. 1 plus 2 is equal to 3, and then it stores the result of the two numbers 1 plus 2 in the third variable, which is called c. So this is the execution cycle. For example, it stores a value in the particular register. We can say C is a particular register, and instruction pointer that points to other instructions that is stored in next address location. So this is the by default way in which CPU works. It executes instructions iteratively in a sequence, and how it gets notified that what is the next instruction. That next instruction is stored in the next address location within the register. So this is how CPU works internally. So this is the diagrammatic representation of the central processing unit, which is called fetch cycle, decode, and execute. Here you can see that this is the first step, which is called fetch instruction. The fetch phase, the control unit fetches instructions from the main memory and then decode those instructions in step number 2. And after that, it transfers those decoded instructions to the ALU. The ALU gets data from the control unit, and after getting data, its purpose is to execute those instructions. Okay, and here you can see there is a specific portion in a CPU which is called registers. You have these registers might be you call them L1 cache and L2 cache or L3 cache. Okay, these are the special registers in the CPU for storing results on temporary basis. Okay, we call them caches, L1, L2, and L3, and their sizes are typically in at least 8 MB, and nowadays the L3 cache comes in the form of 64 MB. Okay, their sizes are in megabytes, 64 and 16 MB. So these are the register sizes: 8 MB, 16 MB, and 64 MB. So we can call those registers as special caches, where the results are stored temporary basis, and after that, when the operation gets completed, those final results are stored back to the main memory. Okay, so this is how the central processing unit works. So this is the summary of the 4 functions of the CPU. First, the instructions are fetched from the main memory, and after that those instructions are decoded into binary instructions by the control unit. So this step is performed by control unit, and after that execute means action and move to the next step. It executes some instructions like a plus b is equal to c, and then move to the next step and then write output to the memory. So this step is performed by the main ALU part. Okay, this step is performed by the ALU part. So fetch and decode is performed by control unit, and then it executes instructions and then store those instructions in the main memory, or we can say in the display. We can also display. So this is all about what is the CPU, how CPU works, what is fetch, decode, execute cycle, and so on. I hope you have understand today's lecture regarding central processing unit. If you have any further questions, you can email me on my official email, which is given there at the end of the slide and the footer area. And till your next lecture, Allah Hafiz.